All right, class, let's get started here. So going on to the third definition of trig functions, I thought this was pretty cool. It is a block or two blocks of wood, and depending on the light that you shine on it, it forms different letters. And this is kind of like what we're doing in trig here. It's kind of, if you view it a different way, you have a different definition of a trig function. And so the first one was, let's go with the first one. First one was like this, is that right? You have a dot out in space, just sort of sitting there. And because of this dot out in space, we form a distance from the origin to that dot right there, and we call it r. And then based upon that, we just start forming all these different relationships, like the y-coordinate divided by the r, that gives you sine. Or the x-coordinate divided by the r value, that gives you cosine. And so we just started this whole new branch of mathematics. We're good? And then we said, you know what? What really happens is each time we really form a triangle. So why not just kind of view it as a triangle, you know, outside of this little x and y grid? And that was formula number 2, or definition number 2. And so how about just a regular triangle out in space like this? That's theta. Now this becomes the opposite side. This becomes the adjacent side, touching there, and this becomes the hypotenuse. And again, we define trig functions that way, right? Just in terms of just a triangle. And this one, we should not accept negative answers, right? Or negative coordinates, because we're talking about just distance, right? So now we go on to number 3 and the last one. Let's jam with it here. Circular functions. So think about it as the outside of a circle. And what does that mean? So I can write that in. 3.4 is the fun section, I say. 3.4 is the one where we're actually going to use it up in applications and stuff. Whenever teacher says fun, right? That automatically is a little trigger. Ouch, won't even ask what happened in 3rd grade, Matthias.
What happened in 3rd grade?
I'll tell you after class.
Okay, are we good? 3.3, definition number 3, circular functions here. So let's start. Let's define it first, and then we'll keep on going. Love it. Okay, let's go back to our little circle. And let's go X and Y grid as well. So instead of a dot just sort of being out in space, what we're going to do is we're going to designate. This might look familiar to you. It looks like a little... We're going to designate the arc on the outside right here, this little piece right here. And we're going to call it a length T. So we're actually taking it as a length from here, and it's almost like if you want to put a shoestring, right? Put a shoestring on top of the circle that you're measuring. And what happens is it's going to form, you know what, it's going to get to a certain dot, isn't it? It's going to get to some dot called X and Y. Wherever we put it, right? Okay, and then we're gonna make this a little circle a little special. We're gonna make this so that it's always gonna be a length 1 away. And so what we got rid of, we technically got rid of R. That's what we wanted to do. All right, if you want to put down here, just put R equals 1. It's fine. So not just X and Y somewhere out in space, but we call it on the unit circle. Cool. Well, with that in mind, so let's define some trig functions here. Tell me if true or false. So sine of t, which is the length of that arc coming around on a unit circle, is just going to be the y-coordinate only. That's it. So no need for r. Let's go back to our regular definitions for sine. Remember, sine, according to theta, was just y over r, right? In a sense, by putting it on the unit circle, what we've done is we've got r to be 1, technically. That's what we got. So this guy becomes a 1. And if that so happens to be, then I got this situation happening. That's kind of what we have. But what we're trying to do is we're trying to get this guy to be a real number. And this guy to be a real number. So it's no longer tied to an angle measurement. We good? It's no longer 50 degrees or 20 degrees or 25 degrees. Because t could be a length value, right? That's a real number because it's just a length. So you got one length compared to a coordinate. That's awesome. That's cool. So that means we have real numbers to real numbers. We can do a whole bunch of different things now. So off the unit circle, or off of the whole concept of having to measure an angle here. We're done. All right, let's go with cosine. Cosine, if I can spell it correctly, that'd be great. Cosine t is equal to the x coordinate. How about tangent? Tangent of t is equal to the y over x. Let me get rid of my chicken scratch. And let's go with the rest of them here. Cotangent, just to write them in, x over y. Everybody agreed there? And we have ourselves, let's go backwards here. So secant. Ooh, secant is just going to be 1 over x. Everybody agreed there? And what's up? Not spelling correctly here. Cosecant is just 1 over y. There it is. Any little conditions here? Yeah, we have some conditions here. X can be equal to 0 here. Y can be equal to 0 here. Again, x not equal to 0 here. And y not equal to 0. Okay, there's my little conditions. X and y are a-okay.
Is cotangent y over x or x? Oh no, wait, I switched them. Nice.
I think, let's see, yeah, I'm going to, since maybe we'll do a calculator kind of thing on Monday as well, as we have homework questions here. I'll skip the calculator thing for now. So let's go for it here. Tell me you guys good? All right, boom. Okay, we practiced a little bit with this already here, so exercise 1, I'm just going to put evaluate. Actually, and draw, that'd be fine. So sine 9 pi over 4. How about this? Tell me what 9 pi over 4 is. Draw it and see what happens here. What time are we at? 9:45? Yeah? So, okay. Okay, yeah. All right, how are we good there? So 9/4. Talk to me here. I think this is 1/4 here, right? This is 2/4, 3/4, 4/4, 5/4. 6/4 comes down this way. 7/4. That's right. Hold on. 8/4. That'd be 2 pi. Is that right? So then if you go over here, we have this. And what we're going to start doing is we're going to start drawing the unit circle this way. I'm going to say that right there from here to here. Nine pi over 4, because it's again, it's a length measurement, right? Not a angle measurement. All right. And now the question is, what coordinate is that is formed by that? I don't know.
2
I
over 2, root 2 over 2, root 2 over 2.
Perfect. Yeah, that little denominator of 4, right, means we're cutting a 90-degree angle into 2 pieces, or 180 degrees into 4 pieces, root 2 over 2. PowerPoint, Microsoft, can't handle. We're doing so sophisticated mathematics. So root 2 over 2, another root 2 over 2, and the answer is it's just this little y coordinate called root 2 over 2. Are we good? Dun, dun, dun.
What does it say, x to the 9? Like 9 of
9 pi divided by 4. Cool, okay. B. Let you guys do one yourself here. All yours. Let's go cosine. Cosine of, that'd be cool. Yours drawing it out with the circular function that we have now. And we're just practicing getting to know this radian measurement here. That's what we're doing here. Monday, it'd be kind of cool to take a look at, because we don't have time right now, take a look at the calculator aspect of it, like drawing it on the calculator and stuff. And then they'll go on to the fun section. 3.4. All right, all yours for drawing it. I have something that looks like this. I think it's the outside is like this, and I think I'm gonna go this way. 7 pi over 6 with quadrant. What do you guys say? 3, I heard. Yep, I go with quadrant 3, and it's just a little bit more, right? It's like right there, right? And I'm purposely not talking about degrees here. Just trying to get us to sort of understand that piece right there. So it's a little bit above or a little below the x-axis, just a little tinge. It's the small triangle away, right? The small triangle away from the x-axis. Can you guys give me the coordinates right there? Square 3 over 2, 1/2. Are we good there? Can we all do that? Because the triangle, just to make sure, the small triangle away looks like this. Here's our little dot. So that means this is the long side right here. This is root 3 over 2. This is the short side. The other way we can have it is the fact that it's a lot further away. It's this far away here, and we're over here. And we got this now situation happening. That's the short side of 1/2. That's the long side of root 3 over 2. We're good? Since we're in quadrant 3, we got negative on our hands. And cosine is going to be the x coordinate only. Forget about the r value whatsoever. We're good? So then it begs the question here. That's the next one. So if I am using this little circular functions here, it's really the same thing as using something called a unit circle, right? R is equal to 1. So let's go back to that real quick here. So I can still use degrees, no problem there. If I say cosine of 240, so this is kind of crazy here. So notice I'm not specifying the r value, right? I'm not specifying another x or y value, trying to figure out where it is in space. I'm just saying it's 240. And what we're thinking about is we're thinking about unit circle. So we're thinking about this little guy like this, and r is equal to 1. So I can think about it degrees as well. So this little third definition, you can kind of flip back and forth between degrees and radians. You're allowed to. So 240, if I were to look this up, this would be a unit circle. R is equal to 1, and 240 is, let's see, this is, that's 90 degrees. That's 180. That's 270, so we're a little bit shy here. So I'm thinking I'm in this little situation with a little 60-degree angle on my hands. Are we good? So that's so cool. Circular functions allow us to sort of think about degrees as well as radians on these guys. Cool, cool. All right. Anybody with the answer for those coordinates? how did we do them? Remember how I think how we do them if we go backwards, right? We can bring this 60-degree triangle back into quadrant 1, is that right? That was the easiest way I think we did it. So bring this guy back into here. This is still 60 degrees. Perfect. This is 1/2 root 3 over 2. Therefore, in quadrant 3, this should be a negative 1/2, negative root 3 over 2. Are we okay? Everybody okay there? Cosine value is negative 1/2. Okay, are we good there? Too easy? I think so. It's kind of more of a, like, just to making sure the definitions are there sort of thing.
So to find that it was 60 degrees, did you take the theta hat?
Absolutely, yeah. Just to write it down, theta hat is 100, so theta minus 180, right? So 240 minus 180 to be more precise for EMEA. Okay. Okay, let's practice. Let's practice with these radian functions here. Let's go the other way. Exercise 2. It says find. Okay, the fun part now. Ready? Since t is the length around, right? T is the length around. Now I can do theta as well, because theta could, let's back up over here. So I'm able to do this in degrees, right? I'm still just thinking about the unit circle though, we're good? And so if that is the case, theta just represents, it could represent the angle. It could also just represent the outside side. It doesn't really matter anymore because you're still getting the same trig functions. Are we good? So maybe this one here, just to prove it, let's go with the proof real quick here. You guys talk to me here, 240. Can you guys convert this into radian measurement? What's 240 in radian measurement? So let's see, the degrees fall out, the zeros fall out. I'm left with 24 pi over 18, and we can divide both those by 6. And we got ourselves 4 pi over 3. So the question is this. I have cosine of 240 degrees equal to 1/2, or negative 1/2. Answer, what is the answer to cosine of 4 pi over 3? Still going to be negative 1/2, right? It's the same thing. In fact, we are kind of just depending what you're sort of measuring. We're either measuring the outside, we're either measuring the inside, the theta here, or we're measuring the t value on the outside. But t value, theta value, who cares? I can just do either one, whichever I like. We're good? Okay, so let's go into this one here. So find theta. For all values, 0 to 2 pi. Zachary beat himself?
Sounds like it.
Okay. So find theta, and notice what's going to happen here. I say theta, but I'm actually talking about radian measurement. And so I have to now, for all the times from in trigonometry from now on, when I say theta, I'm going to have to tell you, is it radians or degrees? Because I can use them interchangeably now. So I find all the theta values for this is true here. So A. Sine theta is equal to a 1/2. So let's go back now to unit circle. And now we're going to go the backwards way. Think about a circle like this. Think about all the coordinates that have a y value of 1/2. That's what I'm looking for. And the 2 pi just means it's one revolution. So if you're one, anybody motion. There you go. All right. Talk to me here. 1/2 would be, that's a small angle away from the x-axis, right? Because it's 1/2, we're going to go up from the x-axis, and I'm looking at something looks like right here, and that will be √3/2, 1/2. I'm also looking at this guy over here with a negative √3/2, 1/2. Agreed, disagreed? Okay, talk to me here. What is the length here, or the theta measurement in radians?
Thank you. Very cool.
pi/6.
Pi/6, absolutely. Okay, Amy, so that's this one here. So now we're gonna go all the way across here and get this guy.
It isn't cheating.
Let's see, if this is pi, say again?
It's just clairvoyance.
Is it 5/6?
I go with 5/6, right? Notice this little angle that we're forming is 5/6, so we're just 5/6 shy of pi. So everybody okay with 5/6? What Adrian's referring to is not cheating. If you look back to the very flip cover of your textbook here, you do have the unit circle. Dun, 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 dun.
So we don't have to memorize it.
What? Just for Grant, I might just do like a unit circle test,
Yeah.
pop quiz or something.
Grant is the only student who can't use any resources to help him.
Okay, are we good there? So just in our minds mentally, just understand. So it's so interchangeable between if we're thinking here or if we're thinking theta here. In fact, if you look at this little guy over here on the back of the book, it actually says 0 degrees or let's see, 30 degrees right here, right? It says 30 degrees and then it says pi/6. And the pi/6 is kind of scrunched in with the angle measurement, right? Even though technically it's the outside, but they're just used interchangeably. When I was teaching high school a long time ago, I had a student, it was calculus class. We were taking the AP exam, got them all prepped. And for some reason, his calculator was in degree mode and he just stuck it in degree mode. So he did the whole calculus test in degree mode. And then only like as he's walking out, he's like, oh, and that was it. So it's not good, did not pass.
Just so I understand, 5/6 is kind of the equivalent, like on the other side, like the quadrant 2 version of pi/6 in quadrant 1.
Okay, am I absolutely crazy, or is that not 5/6?
Probably.
Because aren't there 4?
That's what I was trying to
Because
figure
you had
out.
all like 7/6 earlier, and I was like, that would be where 5/6 is.
Because there's two
No,
pieces.
The whole 180 is just one.
One pi.
but if you look back at this
Pi.
image we drew on Monday or Wednesday or whatever,
Uh-huh.
it's like
We're not starting at the first angle, we're starting at the
Mm.
bottom.
Yeah.
So it
Oh,
goes, it goes,
it looked like
yeah.
it was starting at after the first angle and then you go to the top
No,
of
that's
it.
including both.
Gotcha, sorry. So it's this piece right here.
Okay.
It's the whole thing.
it's like a fraction
Okay.
of pi. Pi equals 180, and so then 6 is like 6 pieces of
Right.
180. So you would start.
Are we good there?
Yeah.
That's cool, okay. All right, all yours, B.
Circle, Adrian, it's a semicircle.
Cosine,
You fool!
let's do this here, -1/2 for cosine.
Exactly, that's it.
So give you guys 30 seconds or so. All yours. And I want you to think through it here. Cosine x value, is that right? It's the x coordinate. So it's going to be the short side. So if it's the short side, it's going to go this way. Since it's negative, I'm looking at something looks like this.
Can I also draw the triangle, like, oh, how do I get that? Like, with the, like, this way, against the,
X-axis or the y-axis?
mhm.
No, it has to be the perpendicular line has to hit the x-axis away from
Okay.
it here. So your position there. So cosine theta is equal to -1/2. All yours here, just to finish off, and we kind of we touched most of the stuff in 3.3 here. Just let's add one more thing in 5 minutes if we can. All right, all yours here. What's theta here? 2 pi over 3. I'll go with it here. Talk to me. How do we get that? It's the small angle here, right? So these are cut into 6 pieces, right? The 1/2 pieces are cut into 3s. Everybody okay there? So if you have the big angle, it's cutting the 180 degrees into 3 pieces. And we're on the quadrant 1 is the first piece of it. This is the second piece, so 2 pi over 3. We good there? And this would be 3 pi over 3. So that means if it's the big angle, this is 4 pi over 3 here and 5 pi over 3 here. Are we good? 6 pi. Sorry, no. Sorry. Yes. 4 pi over 3 here. 5 pi over 3 over here, and this should be 6 pi over 3 because it'll give you 2 pi, right? Sorry about that. All right, 4 pi over 3. Are we good there?
So even though the 1/2 is negative, you don't make the 2 pi and that stuff negative?
No, because
what quadrant it is. Okay.
yeah, this guy tells you which quadrant it is in. This one we're measuring the angles we're moving around. Okay, and one last piece here before we got to go. Exercise 3. It is use a calculator real quick here, just to get us used to it here, to find this is exactly why we use radian measurements here. So on your calculator here, look to make sure you are not in degree mode. Make sure you are in radian mode, RAD. Making everybody get out their calculators with 3 minutes to go in the class. Can't do this to me, Mr. Andreev. Sine of 3.5. That's it. So real quick here, tell me real quick, where would 3.5 be? Which quadrant are we in when we do 3.5? Let's see, I think that's 0, right? This is pi, so that's 3.14, right? So we're a little bit further than that. We're somewhere in quadrant 3, so sine should be negative for us, right?
Okay.
Cool, so if we get a negative value, we're doing good.
I tested it with like, shit.
Let's see, and we're gonna go 4 decimal places for trig functions here. So give me the 4 decimal places. I don't know the answer, I just kind of put this up.
0.3508.
3, 5, 0.08. Are we good? Can I get a second on that?
Yeah.
All right, you guys try your calculators real quick here. Make sure you get that before.
Oh, wait.
Yeah, negative 0.3508. Okay, let's end with that. Just making sure you guys can put it into radian mode, all the good stuff. We did get an email. I just want to acknowledge it. Kat, talk to us real quick here. You're going to Oregon for sure, for sure.
I am going to Oregon for sure. Yeah.
Awesome. Signed and everything?
Yeah.
Sweet. Congratulations to you. That's real good. Awesome. Okay, so boom. Have a good weekend. Don't do anything I would do. And see you guys on Monday. We'll finish up a little bit more of 3.3. Go for any homework questions. We'll go
So
from
we
there.
shouldn't do the homework for 3.3 yet? since we
I
haven't-
say try the homework. I think we've covered most of it except for those when you get to something called parametric equations. It's like a small little section there. And that'd be cool to cover it early on in the class, and then we'll do the homework. Have a good day, everyone. Good. Thank you. Thank you. Bye.
Oh, I have my test correction.
Okay. Yeah, I just want to say, you guys talk to me. Are you guys keeping up with everything? Does it make sense and stuff like that? Are the videos worth watching?
Yeah, so far, I've been keeping up pretty well.
Right. Okay, sounds good.
Yeah, it's just
You
fine.
owe me something? Yes.
Yes.
Okay, cool. Thank you so much. Okay, I just want to make sure that all that is working out. Okay, and then you watched yesterday's video or Monday's video at least? Sorry, if you can
Yeah,
add that.
I watched Mondays, I think, but I'm gonna do Mondays today.
Okay, still good. Okay, as long as we're sort of.
Yeah, I have my test two
Mhm.
corrections and also my test one.
Yes, perfect, yeah. Awesome. Thank you.
Yes.
That is perfect. I'm gonna put it over here with the rest. And we are good to go. Adrian, talk to me, man.
Yes.
How you doing?
All right.
As I spray down chairs, go ahead.
So, did you see my message I sent you on Google Classroom
Oh, I
yesterday?
did not. No, I did not.
Oh, I was wondering if today, during the 3-hour break I have between my elective and after English, or on Monday, would be a better time to take the chapter 2 test.
Okay, I was gonna just have you do it home and then,
Oh.
Dad,
Yeah,
after you,
that-
because it'll be easier that way.
That actually works better than anything.
Okay,
All right.
so okay, I think we're all set.
So
Just to figure,
just like a PDF of it, and then,
yeah, let's see, I need to send it to you then, right?
yeah, but, well, yeah, that will work great too.
I mean, it's honesty as well, you know, just kind of
Yeah,
take
yeah.
the time that it was done in class and stuff. Yeah. Okay.
All right.
Can you just email me or remind me? So
All right.
you can text me or email me the test and stuff.
Thank you so much.
Too many things on my mind.
Yeah, I get it.
And just like one more minute for the stuff, you know, and that's for you guys. So have fun. And good morning. How's you guys doing? How's it going? Thumbs up. This is good. Okay. Maybe bite, and then we'll get started. Actually, how about this? I'm gonna give it. I'm gonna take. You don't need to take temperature, right? You know, there. Thank you so much. How about this? Can I designate a few people with wipes and come on in, and then whoever wants to wipe a few tables, come on in. Then we'll go from there. Got 1, 2, 3, 4. This will be extra process here. So everyone can grab a in here. See? I have them due Friday with, we can, you email me for extra data, that's fine. I think everybody due it late last night.
Nice. That's correct. He's been today or like Friday. Nice. Email like Google Classroom.
Gotcha, okay.
Hey, you're not bad.
It's just so cold.
I lost so many
Stressing me.
I lost so many bets.
Oh, wait, are we all moving?
No, no, but
Yeah.
you can't try to find
Yeah,
what's the last
I like the wall. Just like
For yours, for your corrections?
Yeah.
I did not, sorry, man, I have so many things going on here. I was ready to dig.
Yeah, that was fun.
Okay. I graded mine, I regraded mine to make sure it's correct. And then when I looked at my phone, I downloaded all my pictures. And that's why I didn't have it. So,
What do you need my help?
For good reason.
okay, guys, thanks so much for writing the tables.
Yes.
Yeah. I don't know. I'm
So loud.
Thank you, Kristen, so much.
well, you're across the classroom, so I kind of have to.
It literally just said, smoke.